the two things we want to talk about, wrap up this one, is continuity and intermediate value theorem. Continuity is the idea of not lifting your pencil. So there's three kinds of failures. I hate to bring it up that way, but that's what it is. One is called the point discontinuity. It's called a point disco. By the way, I'm the class of 1981. We killed disco. So when I write disco, it's not. I was not a fan. Never danced disco. Never wore all the chains or the vest. I killed disco. All right. The other one is called a jump disco. Okay. And the third one, anybody know what the third one is? Oh, I forgot. I have them drawn up here already. It's called the infinite. And infinite is just an asymptote. Oh, yeah, they're all disco. They're all discos. Discontinuity. All right? So the point one factors out. The jump one is a piecewise, usually. But it could be greatest integer will work for that too. Have you ever heard of that? Greatest integer, like the phone bill. You're paid so much a minute, or you pay so much a minute. And then this one doesn't factor out. So this is like your 1 over x plus 2. This is like your x squared minus 4 over x minus 2 type. This will factor and make a point disco. This won't factor out. It'll get you an infinite limit. Now there's three parts to proving discontinuity at a point. Okay, and it's pretty easy to prove. Three things. You have to have f of c has to exist. Okay, so let's say you have an equation here, and this is c, and this is f of c. It's got to exist, yeah.
The first example there, that's also a jump, right? No, on the graph.
This one won't be.
No, the red graph on the board that was there before.
Mm-hmm.
That's a jump.
This is a jump here.
The first thing is also a jump.
This one? No, it is not. And we're going to go over it right now. It's still a point discontinuity. The limit as x approaches c of f of x exists. So in other words, the limit on the left has to equal the limit on the right. What do you think the third criteria is? You got this y value. You have this limit. What do you think they have to be? The same, yeah. So the limit as x approaches c of f of x has to equal f of c. And it's a very tiny infraction, but that's what this one is, Kurt. It's a point discontinuity where the y value is defined. It's just not the same. But I'd argue it's not there in the first place. But I'm a realist. I'm not a theoretical mathematician. I'm explaining it from a reality standpoint. Most of math is not reality. It's mental construction to make sense out of logical thought. All right, one last thing. Puppy growth. This is not a true story, and I want that on the record. Okay. So let's say you had a puppy, and at month 3 he was 5 inches long, and in month 12 he was 11 inches long. Was there a time, and his name is Oscar, by the way, was there a time when he was 8 inches long? Yes. Why?
Intermediate value.
What do you mean?
Because it's
Is it? So what if I had some time on my hands in the winter, and Oscar, this is like January, and it's cold, and there's not a lot to do, and I go on the internet, and I buy an Oscar section, okay? And I get it on the internet, and I take them down, I saw them in half, and I put this in here and sew it up, put this in here, sew it up, and then all of a sudden he is 11 inches long. So if we graphed it, it would look like this. This is month 3, this is month 12, and he starts out at 5, ends up at 11. So he starts here and here, and then I could, right here, the great event here, there you go. I would never do that to a dog, by the way. A cat? No, I wouldn't do it to a cat either. But anyways, how many of you have cats? I'm just kidding. I wouldn't do it to a cat. So what you do is, this is what we call a what discontinuity? Jump discontinuity. Are we kind of assuming you can't be a monster? Yeah. And so what kind of growth are we assuming is going on here from 3 months to 12 months? Continuous. Now, it doesn't have to be constant. You could have a little growth spurt in here. But we are assuming that there's never a time where we're doing something despicable and terrible. So what you have to do is, if you wanted to prove this, you would have to show 2 things: betweenness and continuous. Those are the 2 things that you have to show. Betweenness is easy, continuous is easy. But that's what we're going to see with the intermediate value theorem. Well, let's say that we want to show that there's a y value of k, 8 inches for Oscar. Okay? All we have to say is that f, unfortunate letters here, of k is between what 2 things? It's going to be smaller than f of a and larger than f of b. Okay? So we want to show that these 2 values are on the outside. This is on the inside. We also have to show that f of x is continuous on AB. And if we can do that, therefore, f of k exists by intermediate value theorem. So this is like step 1. This is step 2. Okay, show that f of x, f of c is equal to 0. That's what we're trying to prove. We're trying to show that it crosses that axis. So all you have to do in step 1 is show that 0 is between f of 0 and f of 2. And what is f of 0 here? 0 plus -3. And what's f of 2? 8 plus 2 is 10 minus 3 is 7. Is that in there? Yep. And do you see any denominator with an x in it? Or a square root? There, continuous on 0, 2. Therefore, exists by intermediate value theorem. Thank you very much. Don't forget the puzzle for